Today's video, I'll talk about the Diels Alder reaction, which is a reaction between a 1,3-diene, such as this one, with a dienophile. So the dienophile will have one alkene, typically, and the reaction mechanism will look like this, just 3 arrows. But when you draw the product, you want to be aware of the stereochemistry. So because my dienophile is a ring, I'm going to copy out the ring, but leave out the alkene, which donated itself to form 2 bonds, 2 new carbon bonds. Okay, but now the important thing here is because this is a ring, you have 2 H's here, so you're going to get a cis-fused H. It's called a cis-fused H. And then you form a cyclohexane guaranteed on the other side with the 1,3-diene creating this. But now, there are substituents on this 1,3-diene. So how do we know if this should be cis or trans? First, there's a methyl. Now, this segment of the alkene is E, and this segment of the alkene is, it is also E. So you might think, okay, that might be trans because it's E, it's not cis and Z on the same side. But because both of these are E, that means these 2 branches are on the same side of one another. So that means you would need to draw either 2 wedges or 2 dashes. Now, be careful. Because we drew our hydrogens, our cis-fused hydrogens on wedges, we should select dashes for our adjacent substituents here because of steric hindrance. Okay, please remember that. Otherwise sad things happen on the exam. So remember cis-fused H. And also the fact that although these are E, so it sounds like they're trans, you would think you should draw one as a dash and the other as a wedge. But no, because these 2 substituents are both E, that means they're on the same side of one another. So that's how you would draw it for this product. I need to make a note on a few other things. So as we can see, we preserve the stereochemistry, but let's say this time your 1,3-diene is a cyclic compound. Okay. That means your product will be a cyclohexane. We still have the alkene on this side, but because this is a 5-ringed 1,3-diene, the bridgehead will only have 1 carbon. Whereas if this were a cyclohexane 1,3-diene, then we still have cycloalkane down here, but now you would have 2 carbons as your bridgehead. Okay, and let's say you were reacting these things with another ring. You would just attach your ring at the bottom here, and because this is cis to one another, you can choose 2 dashes or 2 wedges. And you would just draw the rest of the ring. So major takeaways is, although this looks like an easy reaction, gotta watch out for the stereochemistry. Remember cis-fused H. Remember that if you have 2Z, or 2 E's and 2 E's, these will mean your substituents will be drawn as a dash or a wedge. But if you have Z and E and Z for your 2 substituents of the 1,3-diene, then you would draw a dash and a wedge. Okay, and as for rings, 5-membered, 1 carbon bridgehead, 6-membered, 2 carbon bridgehead.